Let's do section 10.5, page 528, exercise 5, which reads, use the limit comparison test to determine convergence or divergence of the series. And for exercise 5, we have the series from n equals 1 to infinity of 3n minus 1 over n squared plus 1. Let's begin by reviewing the limit comparison test, which says, suppose that an is greater than 0 and bn is greater than 0 for all n greater than or equal to capital N, where capital N is a positive integer. If the limit as n goes to infinity of an over bn is equal to c, some constant between 0 and infinity, then the series for an and the series for bn both converge or both diverge. If the limit instead as n goes to infinity of an over bn is equal to 0, which is telling us that the terms of bn are bigger than the terms of an, and series bn converges, then series an will converge as well, which is part of the direct comparison test. If instead in the limit as n goes to infinity, an over bn goes to infinity, which means that the terms of an are bigger than the terms of bn, and if the series bn diverges, then an is going to diverge as well, which is also something that we learned in the direct comparison test. So let's go back to our problem. And the limit comparison test helps us determine how a series will behave if we can compare it to another series. So we're going to let the given series be equal to an. And then we need to find the comparison series, or the bn series. So we can use n behavior modeling to find this other series. If we note that as n goes to infinity, our original series, 3n minus 1 over n squared plus 1, that is going to behave as 3 over n. So we could let our bn series be equal to the series from n equals 1 to infinity of 1 over n. And now we can apply the limit comparison test. So we're going to take the limit as n goes to infinity of an over bn. So we're just going to take the nth terms. So that's going to be my limit as n goes to infinity of 3n minus 1 over n squared plus 1 divided by bn, which is going to be 1 over n. Now I know that the denominator of a denominator is a numerator, so I can rewrite this as the limit as n goes to infinity of 3n minus 1 over n squared plus 1 times n. And if I multiply that through, I'm going to get the limit as n goes to infinity of 3n squared minus n over n squared plus 1. And while I could use some n behavior modeling here to solve this limit, I think just to make everything clear, I'm going to divide both the numerator and the denominator by n squared. So that would be 1 over n squared times 1 over n squared. So that's going to give me the limit as n goes to infinity of 3 minus 1 over n divided by 1 plus 1 over n squared. And when I substitute in for infinity for n, 1 over n and 1 over n squared are both going to become 0, and I'm going to end up with 3. And that is going to be my c value from the limit comparison test. And that is my constant between 0 and infinity. And that tells me that the series for an and the series for bn either both diverge or they both converge. So what we need to do is to figure out whether this series converges or diverges. Well, this series is a p-series with p equal to 1. And as we learned in Exploration 1, when p is equal to 1, this series diverges. So if the series of Bn diverges, that means that my series for An, my original series, equal to the summation from n equals 1 to infinity of 3n minus 1 over n squared plus 1 is going to diverge as well.